Okay, we've been given this triangle and this is what we're told. PQ is PR. PQ equals PR, okay? So it's isosceles. S is a midpoint of PQ. S midpoint of that, okay? T is midpoint of that, PR, okay? Prove QTR, that's that triangle there, is congruent to RSQ, RSQ. Okay, so we're dealing with this triangle and that triangle. Right, prove QTR is congruent. Okay, you need to know what congruent means. If two triangles are congruent, then it means, okay, these two triangles are congruent if two sides and an angle. Okay, if two sides and the angle between them are all the same. So for these two triangles, if that side is the same length as that side, if this side is the same length as that side, and if that angle equals that angle, if those three things are all the same, then they're congruent. Okay? So, right, QTR and RSQ. Straight away, they share a side. This side here is shared by both triangles, so one of the three conditions is immediately satisfied. They have one side the same at QR. Okay, so I'll write that here. First condition, QR is the same for both. Right, so if we can show that either QS and TR are the same, or SR and TQ are the same, and that that angle there, or that angle there, if those two angles are the same, or these two angles are the same, then we've won. Okay? Right. It might look like a difficult question. It does feel like a difficult question when you read it, okay? If you get a question like this in your exam, don't panic. Just work through what they've given you and put that information on the triangle, okay? You don't need to know where you're going and exactly how you're going to solve it in order to start the question. You can get started and it becomes clear during the question how you're actually going to get the answer. So this is an important exam, question answering skill. It's important to get used to be able to start a question even if you don't know where you're going. Okay? So, PQ is PR. Let's put that information on the triangle. PQ is PR. That means this whole side here, right, is the same as that whole side there. They're the same. I'm just going to draw it like that for the moment because on the triangle itself we're going to draw this section here equal to that there later on and that there. It's because each of the big sides is split into two. That's why I've drawn them being the same there off the triangle. Okay, S is the midpoint of PQ. S is a midpoint of PQ. Well, if that's the midpoint of this line, then these two are the same length. So we can draw that straight away. Okay? So those two lines mean that QS and SP are the same length. And we can deduce that from S being the midpoint of PQ. T is the midpoint of PR. T is the midpoint of PR. Same thing again. That there, PT, must be the same as TR. So I could just immediately do two lines like that, like here. But that would also mean, if I used one line like that, it would mean that all four are the same. But we can't immediately conclude that. Okay, at this point, we can conclude that, okay? We can conclude that SQ is the same as SP, and PT is the same as TR, so that's the same as that. But we can't say yet that that's the same as that, until we look at PQ equals PR. PQ equals PR, if that's the same as that, now we can conclude that all four of those are the same. Because if that's the same and that's the same, and they're both split into two halves which are both the same, then all of those things must be the same. Okay? So QS, SP, PT and TR are all the same. And we've represented it by these lines here. Right. Okay, well that's all the information we've been given. There's no more, so we've got to try and do some more stuff on the triangle. Right, let's go back to the beginning. PQ is PR. PQ equals PR. The whole thing is isosceles. So that means these two angles are the same. So let's draw that in. I'll use that same colour for the big angle. The whole thing is isosceles, so the big angle, both of those little ones added together, is the same. Okay, so I'll use a double line. Why not? That means that angle is the same as that angle. Okay? Right. Okay, we're getting there slowly. Still don't know where this is going, but we're adding stuff to the triangle. Okay, we're getting as much information from what we're told on the diagram as we can. Right. What else can we say? Well, that whole angle there covers from QP to QR. And we're told that T is the midpoint of P and R, which means that line QT is bisecting this angle, which means that that angle there is the same as that angle there. So I'll use a different colour for that. Let's put that in. That angle there must be the same as that angle there. And same argument on this side. Because S is the midpoint of QP, SR, that line, is halfway between there and there. It's bisecting this big angle. So that angle must be the same as that angle. Okay, I shouldn't have used a single line there because we don't know for sure yet that that is equal to that. So I'll use double lines here and single lines there for the time being. Okay. Can we say that these two angles are the same as these two? Yes, we can, because this side here, that angle there, from T to R, we know that T to R is the same as from S to Q, and they share this side of the triangle, Q to R. So if the base of the triangle, of both triangles, is the same, and this side's the same, TR is the same as SQ, then no, we can't say that that angle is the same as that one from what I was thinking there. No, okay, that's fine. What can we say? How do we know that that angle is the same as that one? Which it is. Okay. We know that that's the same as that. I did this before on paper. How the hell did I do it? Right. Yes, we can say that that and that angle are the same for this reason. Forget what I was saying about sides, that was a dead end, okay? If you come across a dead end like that, no problem. Try and look at it again, which is what I did, and I started thinking about these angles here. We do know that the big angle is the same on both sides. And we also know that these two angles are the big angle cut in two. Each of those is half of the big angle. So because the big angle's the same and they are half of this big angle, then they must also be the same. So we can do that and claim that that angle TQR is the same as SRQ. Okay, so we've done it. We've proved congruency. Because we know that they have the same, well, by they I mean QTR, this triangle, and RSQ, RSQ, they both have this side here. That's the same, it's 0.1, okay? Remember, for congruency, you need two sides and the angle. So that's one side. The second side, SQ, is the same as TR. Okay, they're the same length. Okay, so SQ, I mean, SQ equals TR. Okay, so that's the second requirement of 3. So we've got the two sides, that side and that side, of the two triangles, and now the angle between them. It's the big angle. Sorry, what am I talking about? It's not the big angle, of course it isn't. It's this angle here. Okay, it's that one. Okay, angle TQR, so third point, TQR, the angle TQR equals SRQ. SRQ. Okay? So that angle there is the same as that angle there, according to the arguments we went through at length before. Right, so we've done it, therefore congruent. Okay, let's go through that again, in obviously not as much detail. QR is the same, so they both have this bottom side the same length. Okay, I'll draw them separately. So let's do QTR. QTR. So QTR. QTR. And RSQ. 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 Point 1. QR is the same. Well, they both share this side, so that must be the same as that. Okay? SQ equals TR. SQ equals TR. SQ, that side there, equals TR. That side there. Okay? And TQR, angle, TQR, that's that angle there. TQR, sorry, is equal to SQR. What the hell? TQR equals SRQ. Yes, SRQ. SRQ, that angle there. SRQ, that angle there. Not that one there. Get rid of that. Yeah. Okay, that's good enough. Okay, there you go. So, oh, no, it's fine, it's fine. This is not the angle between them, is it? Stupid. It's fine though, it's because right, different colour. If we can show that TRQ is the same, it's not really a different colour, is it? Oh, it's good enough. If TRQ is the same as SQR, okay? So, we have shown, we know that QR is the same and SQ is TR, okay? So that and that, that's definitely true. 1 and 2 are definitely true. Okay, that angle is indeed the same as that, but we don't want that one. We want the one between it. We want this one. So TRQ, TRQ, it is the big one. Right, okay. So I'll put that in brackets. And just extend that down there and say, it's still true, but it doesn't prove congruency because the angle has to be between the two sides. So, TRQ, not TQR, TRQ, angle TRQ is the same as angle SQR. SQR, not SRQ. That's better. Right. So TRQ is the big one, okay? And we know that they're the same because it's isosceles. So TRQ, that one, is the same as SQR, the big one there. SQR, that one there. Right, now we've got congruency. Okay, again, we don't really need that one. They are the same, but that doesn't prove congruency because they're not in between the sides. So get rid of that. Right? So, now we've done it. Finally. I made a bit of a meal of that. Sorry about that. But I hope that shows some of the thought process. And it definitely shows that I didn't know where we were going when we started the question. Okay? Like I said, for the harder questions, and a lot of questions, you often get these questions that you can't see how you're going to get the answer at the beginning of the question. But you can't just sit there and do nothing because you're definitely not going to get the answer then. You've got to do something. So just start putting pen to paper. Start converting the information they give you onto stuff on the diagram and it will slowly, the solution will present itself. Okay? It's a very important thing you've got to get used to doing. Start the question even though you don't know how you're going to finish it. It does become clear halfway through. If you just get stuff on the diagram, like I say, the solution does present itself. So, That's it. We finally proved congruency. And I didn't actually need to bang on about these little angles, did I? And I'm sure a lot of you spotted that. I could have done this question in a third the time probably, because I got distracted with these half angles. It didn't matter. Just from PQ as PR, the fact the whole thing is isosceles, you can say that the big angle there, they're the same. And then you've done it, haven't you? Because they share the same side, they share this angle, and then you just need to show that SQ is the same as TR. And you know that that's the same as that because that's the same as that, and that whole thing is the same as that. Therefore that's the same as that, therefore that's the same as that. Okay? Right, I'll shut up.